Hi, you might be a little confused when it comes to trigonometry and differential calculus, so today I'm going to run you through all the differential rules that are related to trigonometric functions. This is a video part of a video series that I'm making on differential calculus, so if you don't have the basics or you're still confused about the overall concept or the overall topic, you can go ahead and check that playlist out and watch all the videos to get a better understanding of how everything works. Okay, so let's get into trigonometric functions and their derivatives. So it might be a little daunting at first. There's a lot of trigonometric functions. These are the basic ones that you learn already, and then these are the ones that are a little more, derived or advanced. It's actually just a reminder before we get into this, I guess. A secant is 1 over cosine, cotangent is 1 over tangent, and cosecant is 1 over sine. All right, so these are what these values are. The reason why I wrote them in this order, I will show you. But let's go through the derivatives one by one. This one, you kind of have to remember it, but I'll show you how you can remember it a little easier. So first of all, sine and cosine are a pair. So basically, the reason why I wrote this is because these two are a pair, these two are a pair, and these two are a pair. Okay? So sine turns into cosine when you derive it, and cosine turns into sine. When you derive tangent, it turns into secant squared, which is the opposite pair squared. And then for when you derive secant, it becomes tangent times secant. So it becomes both the pairs multiplied by each other. Same thing with cotangent and cosecant. For cotangent, it becomes the opposite squared. And for cosecant, it becomes cosecant times cotangent. And so it's the two pairs multiplied. Right, one thing you should watch out for is for whichever ones that have a C, so C, this is cosine, this is cosecant, cotangent, everything that starts with a C will have a negative sign in the front. Don't forget that. If you want to remember in a way, you can say pro and cons are negative sign in the front. So then cosine will be negative, cotangent will be negative, and cosecant will be negative. So that's how you should remember all of them. That's how I remember it, and it's actually really easy if you think about it this way. Obviously, cosine and sine are really, really easy to remember, but the way these two pairs work, if you remember them, it's going to be super duper easy. And the negative sign, of course, don't forget to include that. So if we take a look at an example over here, we have the function written to x of x times cosine x squared. So there's a couple different ways we can do this, especially when we're working with these three identities. We obviously know that we can change them into these and derive them because we already know how to derive sine, cos, tangent. But there's a reason why we learned this. It's a little quicker. So let's try this. From the previous video that we watched, we know that, or the previous video that I made, we know that for this kind of equation, it's dealing with a function multiplied by another function, right? This is a function, this is a function. Another thing to remember, this x squared is a function inside a big function. So we have to apply the chain rule. So, okay, let's go ahead and try and derive this. So if there's a function times a function, we always use the product rule. And the product rule is basically you take one function at a time, derive it, and write down the other function the way it is, and then add the two together. So let me show you what I mean. Let's start with this. We derive x, which will give us 1, times, we just leave cosecant as it is, x squared, plus, now we just leave x and derive cosecant. And the way we derive cosecant is according to this, right? We multiply the two pairs together and put a negative sign because it starts with a C. So let's go ahead and do that. If we do negative cosecant, I'll just write cosecant like this, x, cotangent x, x squared, sorry. And then if you leave it like that, obviously you're going to get it wrong because you need to include the chain rule, right? So if we do the chain rule, we need to derive the inside function as well, which will give us 2x, multiply it all, and this will be your first line of working for f of x. Sorry if my handwriting is very, very messy. I hope you can recognize what I'm writing. So if we simplify a little bit, we'll get cosecant x squared minus 2x squared, because the 2x comes out, and then we multiply cosecant x squared times cotangent x squared. And that should be your answer. If you really want to go another step, then you can probably take out the cosecant. That's just factorizing. If you really want to put it that way, you can. I think this will work as a final answer, and so will this. So what I want to show you here, and what I want to tell you, is that this is much faster to do if you really understand how you do this. But if you're in an exam and you just forgot this rule, right, you can always change this to 1 over sine. That might make it easier for you to do. So let's try that. X, and we convert cosecant x squared into 1 over sine x squared. And this will give us the equation x over sine x squared. And this, obviously we know, is a function on top of another function. And so we use the quotient rule. And for the quotient rule, the way we used it was we take whatever is on the bottom and we put it at the bottom and square it first, right? That's the first step. And then what we do is we write down whatever was at the bottom, basically the denominator, and then we derive whatever was at the top, right? Which is just going to be 1. Then we subtract the derivative of the bottom and then copy down whatever was at the top. That result is going to give you sine x squared plus 2x squared cosine x squared over sine squared x. Okay, you get this answer and you might be thinking, oh, wait, hold up. This does not equal to this. At first glance, yeah, it's really different from this. But if you switch up the expression a little bit, then you'll get to this equation basically, and you can prove it, saying that no matter what way you do it, you'll get the same answer. Okay, I'm not going to do it in this video because just for time sake. But if I give you a hint, if you want to try it yourself, you should probably start by separating the fractions and then change all the terms in terms of cotangent and cosecant. But trust me, if you do it, it's going to turn out this way. The results are the same. So that's kind of just an example of how you would deal with trigonometric functions and their derivative. Of course, when it comes to trigonometry and differential calculus, you can't forget the inverse functions. The inverse functions are, well, arcsine, arccos, and arctan. They're sometimes written like this, as an inverse, and this is the notation that you use in your calculator. So you might know it as this. Arcsine, arccos, and arctan mean the exact same thing, so don't freak out. This one is a little bit harder to remember. You just kind of gotta remember it. Repetition will obviously help, but the same rule applies. Because it's cosine, there's going to be a negative in the front. An easy thing about this is that arcsine and arccosine have the same derivative except for the negative sign. So just remember that it's 1 over square root of 1 minus x squared. For arctan, there's no square root and it's a plus sign. So I guess that's kind of the way I would remember it. I just know it because I've repeatedly used it a lot. Sometimes I go back to check again what these are, but for the most part, you should be able to remember it through repetition. So let's finish off by trying an example here. So we have an equation y equals to ex, e to the power of x, arc cos x. So again, this is a function multiplied by another function, right? So we use the product rule. And if we want to use the product rule, we would differentiate the first, or whichever way you'd like to. You can differentiate the second first, but we'll differentiate the first, which will give you ex, and then we'll just write down the second, and then plus we'll write down the first and then differentiate the second, which is going to give us 1 over square root of 1 minus x squared. Don't forget to include the negative. This is going to be the derivative. It's actually quite simple. You can simplify by bringing out the ex by factorizing, and that will give you arc cos x over square root of 1 minus x squared, and obviously don't forget your negative sign. And so that will be the answer. Make sure you don't forget your chain rule. Make sure you don't forget your product and quotient rules. They basically apply to almost every function that you're going to derive. So you really need to grasp this. If you don't remember this, you can check out the video that I made before. There was no chain rule on this because they're all just written to x. But if there was, if there was a 2 here, then you have to remember to put a 2 here. Yeah, that was trigonometry and differential calculus. Not too difficult, okay? Just make sure you remember the way I explained you how to deal with sine, cosine, and tangent, and as well as secant, cosecant, and cotangent. And you can memorize the arc sine, arc cos, arc tan quite easily if you repeatedly use it. So that's it. That's literally all the rules that you need to know to deal with differential calculus. Now we're going to need to go into implicit differentiation and differential equations and applying derivatives in scenarios. So we'll get into that in a future video, but that's it for today. I hope that helped. If you have any suggestions on videos that you want me to make, then you can leave it in the comments below. If you have questions, you can do that as well. I will be replying to every single comment down there. Thank you for watching. Hope that helped. I'll see you in the next video.